In this video, we'll be just using the divergence test to determine whether or not a series is divergent. Now keep in mind again one more time that the divergence test specifies that if the limit of the sequence goes to something not zero, then we can conclude that the series is divergent. Otherwise, we know nothing new. So with this thing right here, I'm going to go ahead and take the limit as k goes to infinity of this interior stuff, this k over k plus 1. So this is me applying the divergence test. So I'm going to, again, abbreviate it div test. So in terms of this, the limit as k goes to infinity, well, the top goes to infinity, the bottom goes to infinity. You could either choose to use L'Hopital's rule, or you could go ahead and multiply top and bottom of this thing by 1 over k, the largest power of k in the denominator. I'm going to go ahead and multiply by 1 over k because it is more consistent and it works more effectively in all cases as opposed to just some. I will manipulate and simplify this limit such that the limit as k goes to infinity becomes 1 over 1 plus 1 over k. And as k goes to infinity, this term goes to 0, but I get 1 over 1, which is just simply 1. So, based on the div test, with the div test limit of k equals k going to infinity of this sequence equals to 1, I can conclude that by the div test, the series k over k plus 1 is divergent. And again, it's divergent specifically because this wasn't equal to 0. If it was equal to 0, then we would have no new information about what this series is going to do. So let's take a look at another example. The other example is the summation of k equals 1 to infinity of 1 over the square root of k. In this example, again, we're just going to apply the div test, the limit as k goes to infinity of 1 over the square root of k. As k goes to infinity, this thing does end up going to 0, which again doesn't provide any new information. So this test, the div test specifically, is inconclusive. If it was equal to anything other than 0, then we would be able to specify that this thing will diverge. If it's equal to, say, 1, 12, 17, 9, negative 3, infinity, then again, we can conclude that the series as a whole, the series, will diverge. And again, notice how I specified that up here, that the series is divergent. Notice how I didn't specify anything about a sequence in the statements of how I wrote this, because it's not about the sequence. We don't care what the sequence in here does. We want to know what is the sum of this sequence. So the limit of the sequence provides us with 1, therefore by the divergence test, the series is then divergent. Let's go ahead and look at one more example. That example will be the series of 1 plus 3 to the power of k over 2 to the power of k as k equals 1 to infinity. Now what you might consider for this one is that it looks very, very similar to that of a geometric series. And again, we could use a geometric series rule to evaluate this. Now that's not what the question is. The question specifically says use the divergence test to determine if the series is divergent. And if I manipulate this using the div test, again, my geometric properties, what I'm going to conclude here is that this one is definitely a convergent geometric series because my r value is 1/2, but this one is not. This one is actually a divergent geometric series with 3/2 as my r value. So I can't conclude that this thing as a whole will be convergent. So in reality, yes, I could look at this as though it's geometric and I could attempt to use the properties in the previous videos, but the problem with those properties is that it comes to a conclusion that one of these is convergent, one of these is divergent, and I can't guarantee that this thing as a whole will converge or diverge separately. Again, we don't have a rule for if two things add together and they diverge. Now, logically, we can come to the conclusion that if I have a series that converges added to a series that diverges, well, then the overall thing should diverge because, again, it increases without bound. But it is possible for us to have two logically divergent series doing the opposite things of each other, where they're oscillating in some way, that they can conclude that we end up with something that is convergent to, say, something 0 or 1. But in this case, because of the way the nature of geometric series are, we would be able to argue logically that these things diverge. But let's actually prove that using the div test. So I'm going to go ahead back to this thing right here. I'm going to take the limit with the div test as k goes to infinity of 1 plus 3 to the power of k over 2 to the power of k. Now I will actually end up going ahead and doing the exact same thing with this, such that this is equal to the limit as k goes to infinity of 1/2 to the power of k plus 3/2 to the power of k. And as k gets larger and larger, this thing gets smaller and smaller. And as k gets larger and larger, this thing gets larger and larger. And again, if I'm adding these two values together, there's nothing wrong with this. Now, if they were multiplied together, we'd have difficulty with these limits. But because this thing is added to this thing, 0 plus infinity will simply be infinity. And therefore, we can conclude that by the div test, and the limit does not equal to 0, the limit of that a sub k does not equal to 0, then the series of 1 plus 3k divided by 2 to the power of k is divergent. Again, it has to be not equal to 0 for the original series to be divergent.